Hello everyone. In this video, we will be discussing about chapter 4, lesson 7, that's about triangle congruence. So this triangle congruence is called CPCTC. Okay, yes, it does look something different rather than SAS theorem. It's similar to that. Just like how we call side angle side SAS or AAS, it's something similar. So we call this as CPCTC. So let's go further and see what does the CPCTC mean. So CPCTC is an acronym for corresponding parts of congruent triangles are congruent. So they have just taken the first, instead of writing from here till here, because it's a very long kind of uh, name. So just to shorten it, it's an acronym written corresponding, so C from corresponding, parts P of congruent, so C again for congruent, triangles are congruent. So they have just taken the first letter of each word and then they have shortened it as CPCTC. So CPCTC means corresponding paths of congruent triangles are congruent. Now from this itself, you could find out what the lesson is going to tell you. Means the corresponding parts of two equal triangles. So the two triangles which are equal, their corresponding parts are congruent. They are equal as well. If two triangles are equal, definitely their sides are going to be equal as well. Okay. Now, yes, this is going to be a little bit what do you call a lengthy one, a lengthy video, but that's because I'll be showing you a bit more questions to solve. But other than that, it's going to be an easy one. I will try my best to shorten the video. Okay. So it means that once two triangles are proven to be congruent, so once you have proven that two triangles are congruent, as you know, for proving congruent triangles congruent, we use SAS, SSS. You all are very familiar with those theorems now. So once you have used any one of those theorems and proved that two triangles are equal, so the remaining part, the remaining side or the remaining angle, we say it is congruent due to CPCTC. Okay, so it is usually used at the end of a proof to show that two angles or two sides are congruent. For example, I'll make it easy for you. Now say that you have used SAS theorem to prove that two triangles are equal. So in SAS theorem, you have used two sides and one angle, right? So the sides which are not used and the angles which are not used, we say they are also congruent due to CPCTC. So once you prove it, then remaining one you say as that remaining parts of the triangles are congruent as well. So here you can see if ABC is congruent to KLM, then all the corresponding sides and angles of the triangles are congruent. You know how to read congruent triangles now. AB is congruent to KL from the sign, AC is congruent to KM, and CB is congruent to ML. And same way, the angles are congruent too. All right. Now, again, this is just a quick um, remembering of CPCTC. Corresponding paths of congruent triangles are congruent. Okay, now let's see what does this CPCTC does here. A landscape architect sets up the triangles shown in the figure to find the distance JK across a pond. So he's finding the distance across a pond JK. What is JK? So they want you to find what is JK. Now you could see that they have given from J to L it's 19, N to L it's 19, which means they both are equal. Similarly, M to L is equal, K to L is equal, which means ML is congruent to KL. So simply we could say JK is also 41 because MN is 41. MN is congruent to JK. So that's going to be 41. But it's not so simple just to say 41. We need to prove. So first let's prove this, that these two triangles are congruent. So to prove this, already we have two sides and the angle. You know this is vertical opposite, they are vertically opposite angles. So we can use SAS theorem to prove that these two triangles are equal, right? We are using this side. We have to say JL is congruent to NL and ML is congruent to KL. There, that is two sides. And we could say angle JLK is congruent to angle NLM because they're vertically opposite angles. So therefore, triangle JLK LK is congruent to MLN because of the side angle side theorem. So what does that mean? If two triangles are congruent, definitely the remaining length, that is this length, is equal to this length. So by CPCTC, JK is congruent to MN. So JK is equal to MN, which is equal to 41 feet. So remember, we use CPCTC only when we use another theorem to prove that two triangles are equal. First, we need to use a theorem to prove that two triangles are equal. Then you will use CPCTC to prove that the remaining sides are equal also. Okay, let's look at one more example. PR bisects angle QPS and angle QRS. So you could see this QPS and QRS, right? So it's bisecting angle P as well as angle R, which means now you know QPR is equal to SPR. This angle is equal to this angle. Similarly, here this angle is equal to this angle. You have to prove that PQ, this is congruent to PS. Now from this information which is available to us, what is the theorem we are going to use? This, you know, this is PR is equal to PR because of the reflexive property. So already we have one side, right? So the next one, they have already given out. This is, I'm using just a flow chart to show you how the figure looks like. Okay, so this is given. So because of this, what happened is we can say angle QPR is congruent to angle SPR. As you know, I already explained these two angles are congruent because it has bisected. Bisect means dividing two equal parts. Similarly, QRP is also congruent to SRP. This angle is equal to this. So now we have one side, this side, we already know that PR is congruent to PR because of the reflexive property. We know this angle and this angle are equal to the others in the triangle. That means we have two angles and a side. Now this is the included side. So which theorem are we going to use? We are using ASA, angle side angle, right? So because of ASA theorem, we could say that two triangles are equal. So what does that mean if two triangles are equal? That means you could say PQ is also congruent to PS because of CPCTC. See, I told you already you need to use ASA to prove, you need to choose any other theorem to prove. Okay, then remaining parts of angles of the triangle, you will say they are equal due to CPCTC. Okay, now it is easy, okay, but only thing is that you need to be a bit um, vigilant, you could say, right? Okay, now this one, J is the midpoint of KM and NL. So they're talking about J, which is the midpoint of KM, and NL, which means KJ is congruent to MJ, NJ is congruent to LJ, right? This is equal to this is equal to this. You need to prove that KL, this part, is congruent to MN. Now we have to prove this part means we need a triangle concerned with this part, which is related to this part. Now because we are going to prove KL is equal to NN, we cannot use KN because that is nothing to do with this part. So we have to consider the triangle which is to do something with this part. So which triangle is that? That's triangle KJL and NJM, right? Now from these two triangles, we need to use any other theorem and prove that they both are equal. So how are we going to prove that they both are equal? So simply, you could say, okay, you could say that, okay, first we need to prove that triangle KJL is congruent to triangle MJN. So which theorem are we going to use? Now we know this side is equal to this side and this side is equal to this side. So we have two sides. And also we know this angle is congruent to this angle because they are vertically opposite angles. So which theorem are we using now? We are using SAS theorem, side angle side theorem. So this is the reason. So because now two triangles are equal, we already proved that two triangles are equal. Now you could say that KL is congruent to MN, is parallel to MN because of the CPCTC TC. In fact, here one step is missing. It should be first KL is congruent to NM. Then you could say KL is congruent parallel to MN. Okay, because of the definition of parallel lines. All right. So I think let's start. Let's try out some questions so that your doubt will be cleared as well, right? Okay. So question number 2, here they are saying, an archaeologist wants to find the height of AB. Okay, let's first. Okay. So he or she, whoever it is, this archaeologist wants to find the height of AB of a rock formation. She places a marker at C and steps off the distance from C to B. Then she walks. Okay. If DE is 6.3, so this is going to be 6.3. DE is 6.3. What is going to be AB? Now, simply we could say AB is also 6.3, right? But no, we need proof. So they have given that this part that is from C to D is equal to C to B. So first, let's write it down. Let's write it down saying DC is congruent to BC. Because it's already given information, they have already marked that for us, right? So you could write this as given. Then what's the next thing? They have given you two angles, right? You could say that angle D is congruent to angle B because of the right angles theorem. Because they're right angles, you can see that they're right angles. You have to say, in fact, right angles congruence theorem because they both are equal, right? Now, which other parts do you think we could use? We can say that CE is congruent to CA also, right? CA is congruent to CE because the C is acting like a midpoint. So you could say the definition of midpoint here, because it's a midpoint, they both are equal. So finally, you could say that DE is congruent to AB. So which theorem did we use here? I forgot to ask that. So which theorem? Or you could even say here the vertical angles. They are vertical angles. If you notice them carefully, they are a pair of vertical angles. So instead of using that side, we could say that angle DCE is congruent to angle ACB because of vertical opposite angles, right, theorem. So finally, you could say that, I even forgot to write the step here. So finally, we can say that triangle, let's start from here, CDE, so triangle CDE is congruent to triangle CBA because of which theorem? Which theorem did we use now? We used this side and we used these two angles and we used this angle. So what kind of theorem is that? That is ASA, angle side angle. Finally, now you could say DE is congruent to BA because of CPCTC. So BA is also equal to 6.3 meters. See, as I told you, first we need any other theorem to prove that two triangles are equal. Then we will say because of they are equal, they are congruent. Then because of that, the other sides are congruent as well due to CPCTC. Okay, moving to the next question. X is the midpoint of ST. Now you know what the midpoint does. It divides the segment in two equal parts. RX is congruent to ST. Prove that RS is congruent to RT. Now, this already I don't need to tell you. You know what kind of theorem we use here. I mean, which property we use here, right? Okay, so let's start with this. RXS and RXT are right angles. So what kind of theorem can we use here? Because they're talking about right angles, we could say that they are right angles theorem, right? or because here they're repeating, we could say this as okay, let it be. It's okay. Let that be right angles theorem. Okay. Now they are saying again, they're talking about angles again. RXS is congruent to RXT. Again, they're right angles congruent, you could say. It's a right angles congruence theorem, right? Because they're right angles, so it really doesn't matter. Rx is equal to Rx due to this is your favorite, most of your favorite theorem, right? That's going to be reflexive property, right? Then Sx is congruent to Tx. So Sx is congruent to Tx. Why did this happen? Because of the midpoint, right? So here we are going to say definition of midpoint. Then finally, what are the things we are using? We use this side, we use this angle, and we use this side as well. So it's going to be side, angle, side. So finally, we can say that triangle, we can say RXS, it's a triangle, so you can name it however you want, is congruent to triangle RXT. So because of the SAS theorem, right? Then you can say RS is congruent to RT because of the CPCTC. So the remaining part of the triangles are congruent as well. Okay, let's move to this. Here you have to just again fill in the properties. So AC is congruent to AD, CB is congruent to DB. It's given. It's already given in the question. We need to prove AB is bisecting angle CAD. So we need to prove that it's bisecting this angle. Which is the reflexive property of congruence? It's AB is congruent to AB. Okay. So triangle, now they're talking about triangle ACB. ACB is congruent to triangle ADB. Now, what do you think we are going to write here? Because of what? We are going to write which property we use. That's why they're talking about triangle congruence, right? So already they used two sides here. They used AC and CB. So two sides, and which angle did they include? They didn't include any angle. They only talked about sides. So they talked about AC, they talked about CB, and also they talked about AB. So which means they talked about all the three sides. That's going to be side, 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 right? Because we are using SSS theorem here. Now, triangle CAB is congruent to DAB. Why? Because of CPCTC, right? Once you have proven that the two triangles are congruent, that means the remaining parts stay congruent as well. So that's why we could say CAB is congruent to DAB, right? So because of CPCTC. Now, why is AB bisecting CAD? Due to what? You could write here definition of bisector. Angle is definition of angle bisector, because they're talking about angle, right? They said that angle A has been bisected. So definition of angle bisector. Okay, let's move on to the next question. To find the distance AB across a river, so they are going to find the distance across AB. They want to find this. A surveyor first locates point C. He measures the distance from C to B. Then he locates point D at the same. So that means this is acting as a midpoint now, because they're saying this is congruent to this. They both have the same distance. If DE is equal to 420, so this is 420, what is AB? Easily you can find out that it's 420 as well, but we need proof for this, right? So we already have two sides. So let's start by saying that BC is congruent to DC, because that's given information, right? That's given already. They said it's the same distance. which means, or you could even write definition of midpoint, no problem. Okay, because this C acts as a midpoint, so definition of midpoint goes well there too. Next one, they're talking about two angles. Now they already gave angle ABC is congruent to angle ABC is congruent to angle EDC, EDC, because of the right angles congruence theorem, right? Right angles congruence theorem. Okay, so we are using this angle, we are using this side. Now what else can we get from this info diagram? We could say that these two are congruent as well, because they are vertically opposite angles, right? They're vertical opposite angles. So we could say angle BCA is also congruent to angle DCE because they are vertically opposite angles. Fine. So we have used this angle, we have used this side, and we have used another angle. So we have used two angles and the included side. So now can we say that triangle ABC is congruent to triangle EDC because of angle, side, angle. Right? Now we can say that AB is congruent to ED as well. So AB is congruent to ED because of what? CPCTC. Now we could say that this is E, right? AB is equal to 420 feet. So this is how you need to prove. Hopefully the lesson is clear. It just needs a bit of practice, nothing else. Just a bit of practice and you can become perfect in that. So one more last question, we will try to solve this. WX, so WX is congruent to XY and YZ, it's all the sides are congruent. So we need to prove that angle W is congruent to angle Y. Okay, now we know that this side is equal to this side is equal to this side is equal. All of them are equal to each other, right? So we are already using two sides of the triangle. So we will first write this as given. Now I'm not writing that step. Okay, let me write that. WX is congruent to XY, which is also congruent to YZ, which is also congruent to ZW, because this information is all given. What else information can we get from this figure? This thing, ZX is congruent to ZX because of the reflexive property, right? Then finally, you can say triangle ZWX is congruent to triangle ZYX because of what? Which theorem did we use here? We have used side, side, side. So S, S, S. Now can we say that triangle, not triangles, can we say now angle W is congruent to angle Y? Yes, we can say angle W is congruent to angle Y because the corresponding paths of congruent triangles are congruent. So once you prove that the triangles are congruent, then the remaining parts become congruent too. It's not a difficult lesson, right? So you could try some more questions. So we'll meet again in the next video, which is going to be the answers for the homework. Till then, try to do some questions and practice.